Hey, Math 110 students, welcome back to Chapter 3. And today we're going to talk about the conjugate pairs theorem. And this is about two pairs of zeros that always go together in a polynomial function. Think about the word conjunction. In English, conjunction is the form of speech that joins two things or when two things go together. So you have A and B. Okay, or A or B. All of these are joining words, and that's what the conjugate pairs theorem talks about, factors that are always joined together. But before we do that, I want to first share with you this screen, and I want us to review real quickly. I think it'll be in our best interest if we review FOIL and special product rules on these guys. All right, let's say I did FOIL here on this first one. FOIL is where you multiply the first terms, the outer terms, the inner, and the last, and this works for binomials. Binomials are the parentheses that have two terms in them. So I've got a term here and a term there. So this is a binomial, this is a binomial, and I can multiply two binomials using FOIL. Multiply the first term, so x times x is x squared. Multiply the outer terms, x times 3 is positive 3x. Multiply the inner terms, negative 3 times x is negative 3x. And then multiply the last, L for last terms, negative 3 times 3 is negative 9. Middle terms here cancel out, and we're left with x squared minus 9. Now, these that follow this pattern of x minus 3, x plus 3. By the way, these are what we call conjugates. If you have the same thing and the only difference is the sign in the middle. Then we also have something called a special product rule, where if you multiply conjugates like a minus b times a plus b, you get a squared minus b squared. The first thing's squared minus the second thing squared, because the middle terms, just like these, will always cancel out. So instead of using FOIL, I can just use the special idea that works for these types. And this will be x squared minus 25 because the middle terms here would cancel out. All right, now, I may be going fast, but I'm never going too fast for you. Why? Because I'm recorded. So you can't say she goes too fast. Why? Because you can slow me down. You can't say she never repeats herself. Why? Because you can rewind me. All right. So if I'm going too fast, slow me down. If I'm going too fast, go back and rewind me. If I'm not repeating myself enough, then stop it and go back. All right. That's the beauty of the video. All right. So now we've done this special idea. How do we multiply these guys that are conjugates? X minus I, x plus I. Now I'm adding an imaginary number in here. All right. Well, if we were going to do it by hand, we'd go x squared. I mean, if we were going to do it with FOIL, x squared plus ix minus ix minus I squared. And the ix's would cancel out. Or we could just say it's the first term squared minus the second term squared, minus I squared. By the way, if you remember from our discussion on imaginary numbers, what does I squared equal? That equals negative 1. So this is x squared minus negative 1. This is x squared plus 1. All right. How about if we were taking x minus I and we were squaring it? Okay. Then this would be x minus I times x minus I. This would be x squared minus ix minus ix plus I squared. That's using FOIL. So x squared minus, I have two of these, minus 2ix plus I squared is negative 1. So I basically have x squared minus 2ix minus 1. This is not as important. This one right here for today's lesson, this is the super important thing. So if you don't understand that one, go back and rewind it. All right, now with all that said, Let us go to our PowerPoint slides. And we are going to, oops, not that one. Use the conjugate pairs theorem today. All right, what is the conjugate pairs theorem? Well, let's see. We've already defined complex zeros. A complex zero, no, I don't want that. All right, every complex polynomial function has at least one complex zero. And so these would be the zeros that could be our real zeros, but it also could include imaginary zeros. All right. I don't need that. All right. Use the conjugate pairs theorem. Here's what I want you to know today. If you have a zero that is a complex number, a plus bi, then its conjugate is a minus bi, and that will also be a zero. And a polynomial function of odd degree with real coefficients has at least one real zero, but all of them are going to have at least one complex zero. All right, so those are words. Let's put it into action here, and let's talk about this for a little bit. All right, let me get a special pen. All right, polynomial function of degree 5, so it could have at most 5 real zeros, but it's going to have 5 zeros that just might be imaginary. All right, it has real numbers, has the zeros 2, it has the 0, 4i, and it has the 0, 3 plus I. So we have a 0, 2, 1, 2, 3 of these zeros. 4 plus I is 0 plus 4i. All right, so its conjugate will be 0 minus 4i, or just negative 4i. So now we have zeros of 2, 4i, and if we had 4i, then we have negative 4i. We have 3 plus I, and if we have 3 plus I, then we have 3 minus I. Notice only the sign in the middle changes for the conjugate. All right, so these are our zeros. And notice that we have 1, 2, 3, 4, 5 of them, although 4 of the 5 are imaginary, only 1 is real. So when you graph this, this function would only actually cross the x-axis at 2. All the other zeros are imaginary. Okay. All right, now let's say we know these zeros and we want to find the polynomial that goes with it. All right, so we have function of degree 4, so it's going to have 4 complex zeros. Zeros are negative 2 and 2. Those are real ones. It has an imaginary 1, 3 minus I, so it also must have an imaginary 1 of 3 plus I. All right, that's the conjugate pairs theorem. All right, so now let me show you this. All right, now here's what we know about our function. It could have any a value out top. We're just going to assume that that a value is a 1 for errors, and we're going to come up with a polynomial function. The easiest one is that the a is 1 that has these zeros. Well, if it has a 0 of negative 2, remember that the factor is x minus the 0, so x minus negative 2, and that's how they get x plus 2 here. Then we had a 0 of 2, so the factor then is x minus 2. That's what they've got there. But then how do you write the factors that go with 3 minus I and 3 plus I? This is going to be x minus the 3 minus I and x minus the 3 plus I. And we'll have to distribute this negative all the way through. All right, so we've got it all worked out here. And let me show you step by step. So this is what we wrote out first. Okay. Now look at what they did. They went ahead and multiplied x plus 2, x minus 2. That's the kind where it's a plus b, a minus b. So they squared the first term, the middle term is canceled out, minus squaring the last. So that's how they got x squared minus 4. Then they rewrote these, so these also fit that form. So they put the x minus 3 first, and the minus I outside. And then again, the x minus 3 first and the positive I outside. And now they're going to multiply these two. Well, they can multiply these two using the same method that they used for the last one, and it's going to be the x minus 3 squared, okay? Again, with the minus sign of the last term squared, the I squared, all right? So if you don't understand how they got from this step to this step, then pause me, rewind, and listen to that explanation again. All right, now we've got x squared minus 4, x minus 3 all squared. If you use FOIL on it, that's going to be x squared minus 6x plus 9. Minus, there's my minus, and I squared is negative 1. So now I've got minus negative 1, and I just need to be careful. It's not terrible. This is Algebra 2 simplification. We just need to keep it straight and make sure we're writing it neatly and correctly so we don't make careless errors. So now I have x squared minus 6x plus 9 minus a negative 1, which is plus a positive 1. 9 plus 1 is the 10. And now we have all this, x squared minus 4 times x squared minus 6x plus 10. So I've got a binomial times a trinomial. The rule is everybody in the first gets multiplied by everybody in the second. So x squared times x squared is x to the 4th. X squared times negative 6x is negative 6 cubed. X squared times the 10 is 10x squared. Now the negative 4 times the x squared is negative 4 squared. The negative 4 times the negative 6x is the positive 24. The negative 4 times the positive 10 is negative 40. Now we can just combine our like terms. That's x to the 4th minus 6x cubed. 10 minus 4 gives us 6x squared plus the 24x minus 40. And you could have any a value out here. In other words, there are a bunch of different polynomial functions that will have these zeros. I like to just use a as 1, and that would be the simplest one. X to the 4th minus 6x cubed plus 6x squared plus 24x minus 40. All righty. That is it for this one. For this video, part A, it's conjugate is our keyword, and you can email that to me. We'll finish up in another video.